Hi, this is Alyssa Borelli, website editor for Commercial Integrator. Today, I'm delighted to have Rob Moodey, Manager of Strategic Partnerships at Matrox Video, joining in on a discussion about the command and control room market. This is, of course, part of Commercial Integrator's Command and Control Deep Dive Report in the August edition of Commercial Integrator and Security Sales and Integration. This will also be spotlighted throughout the month of August online. Welcome, Rob. So great to have you here today.
Very pleased to be here.
Let's jump right into it. How critical is the ability to handle high-resolution 4K and 5K content in command and control room environments for rapid decision-making? Can you share some examples where this capability made a difference?
Well, there was a time when 4K displays were unusual in the control room, but now it's fair to say they're commonplace. And let's face it, no one wants to buy performance and then not use it, do they? And the systems behind the displays, the workstations and the wall controllers need the capability to energize those resolutions. A related trend, I think, is the improving pitch of LED. There was a time when that sort of technology couldn't get enough pixels into the available space in the control room. Not the case now. And LED, of course, is not constrained to the traditional VESA resolutions either. So previously, LED was limited by the number of pixels that would fit into the space. But now the designers are able to consider the number of pixels that they can actually use. And that's becoming the limit of how much info we can usefully put on the control room wall. And cards like the Luma Pro are delivering it to both the LED and increasingly the high-res panels as well.
What challenges do organizations face when integrating high-resolution content into their existing AV systems, and how can these challenges be overcome?
Pixels are the challenge, really. We've just spoken about displaying them, but we've got to get them into the system as well. And more pixels means more bits per second, more bandwidth. Unlike motion video, the sort of information that we put on the walls in the control rooms can exploit those pixels. We can easily see that the smallest text is not quite as sharp as it might have been, whereas we might have found it a bit difficult to perceive any softness in motion video. Process control rooms have got increasing amounts of data that they're trying to bring onto the wall as dashboards or some other format. And Matrox has spent the last few years refining how to get those high complexity media into the display systems, and it shows in the product line. Cross-physical captures like HDMI and network captures as well. But however it's captured and displayed, the users need to read it without introducing the psychological stress that goes with poor display quality. If you can imagine someone saying, oh, they can just about read it, that's really not a good recipe for the well-being of staff who are making critical decisions.
Can you explain how video compression technology, particularly using codecs like H.264 and H.265, help in achieving efficient compression without sacrificing image quality?
Sure. More and more of the content for the control room wall is arriving via a network connection. It might be video, it could also be a computer desktop that's being streamed. And to make the best use of the size pipe they have, their network, any incoming real-time images are often compressed. That's where H.264 and H.265 come in. They are among the dominant codecs with the ubiquitous 1 gigabit per second networks. With streaming, the designers are trading three things off against each other: the quality of the image, the latency or the delay, and the bandwidth being used. And with a given codec, you can improve two things only by sacrificing the other. Now, some organizations conclude they're limited by their network bandwidth, so they have got to compromise one of the remaining two, accepting latency to get quality. Matrox Mavex codecs address both H.264 and H.265, letting the majority of users explore just what they can achieve with their network. And they are often very pleasantly surprised just how small the latency is. 50 milliseconds or so wouldn't be unusual. Others are increasing the network bandwidth to, say, 2.5 or 10 gigabits per second, and finding that then they're able to use higher fidelity media, higher resolution, more colors, better frame rate, and so on. And the extra bandwidth often leads them to explore different compression regimes too, as well as the ones you mentioned, other codecs, maybe like JPEG XS.
With the growing emphasis on security in command and control rooms, how critical is it to implement strong authentication measures such as 802.1x?
The bad actors out there will often target control rooms and control systems in general. So it's vital that these are not neglected when cybersecurity is being considered. And as streamed material is typically coming from outside the control room, authentication, like 802.1x, is vital. Is it the right source at the right network port? Can we trust what it's giving us? And the wall controller has got to authenticate itself too. You know, the ethos is trust nothing. And having role-based permissions is important too. So your wall control systems need to have things like Active Directory, limiting who can do what. That's part of the security as well.
Why is open standards-based transport, such as IPMX, essential for ensuring interoperability in AV systems? What cost savings and efficiency benefits does it offer to integrators managing these complex AV setups?
IPMX is indeed a suite of standards and open specifications like NMOS and others, and it's offering great flexibility in control room design. And that flexibility is saving money later on. It's only a few years ago that those folks operating the control rooms suddenly found they needed flexibility to do things they had never expected to need to do, like spreading the people across several rooms so would get 2 meters between them each. Remember the components crisis? They found they could only get some brands, not necessarily their preferred one. IPMX and its openness and the products designed to support it are offering interoperability between brands, bridges between technologies, and the ability to scale across sites if you need to spread the people out. Now, historically, control room designers planned for the expected. And having recently been faced with the unexpected, they now recognize the value in having a core system, and AV over IP is a core system, that can be expanded in multiple ways rather than one that's locked into a relatively narrow range of options.
What are some key considerations when managing both compressed and uncompressed video transmission within these environments?
Well, the IPX suite we just mentioned has already bridged the routing of mixed signals, including uncompressed and compressed, because it's a single system that can support multiple different bandwidths, different network architectures, and I'm thinking particularly of precision timing protocol network timing, because that's needed in some sensor networks in process automation. And of course, it's used in some media networks too. And also we've got the multiple different compression regimes we spoke about, multiple different technologies, and in some control rooms, even spanning across multiple organizations. In summary, the wider the interoperability story, the more maneuvering room you have, and the better you're able to react to the unexpected.
Is there anything else you'd like to add? Do you have any closing thoughts?
I'd like to end by noting an industry trend that I think is probably becoming obvious to almost all of us, and that is simplification of connectivity. The futurologists tell me that in a few years' time, the connectivity on AV devices will be dominated by only two forms, either or both of a USB derivative intended for in-room connectivity and a network connection, whether that's copper, glass, or wireless. It's intended for room to room and beyond. Of course, it can also be used in room. And that means HDMI, DisplayPort, SDI, DVI, and all the I/O ports we're familiar with are moving into their sunset. And we can all see that trend to be well underway. The number of connections on the side of our mobile phones is dramatically smaller than it was a couple of years ago. Have you tried to buy a laptop recently without USB-C on it? Conversely, have you tried to buy one with HDMI on it? That's no longer a given. And taken together, that all means that our control room connectivity will be almost exclusively network-based, but probably with a number of different IP variations on that network: SRT, NDI, RTSP, JPEG XS, HEVC, and so on. And that's the clarion call. Be ready to be flexible to handle any or all of that, because, as the military say, a plan, even a good one, rarely survives first contact with the enemy. Matrox is a proven survivor, 48 years of history, with the sort of partner you'd want on your side. That's my final thought.
Wow, well, thank you so much, Rob, for joining me today. And thanks again for sharing your expertise with me.
It's been a pleasure. Let's look forward to next time.
Please check back on commercialintegrator.com throughout the month of August, and of course in print for all things command and control room related.